what Gay-Lussac's law says is that when you have constant volume, okay, with each of these laws, you're going to have three variables: pressure, temperature, and volume. Okay, so that's the first thing to keep in mind. With these laws, three variables: temperature, pressure, and volume. With each of these laws, one of those parameters, one of those variables are going to be kept constant just so that you can study the other two and that kind of relationship. So that's sort of like when you're designing an experiment in chemistry, you only want to look at two things just so that you can see how they relate to each other. And then you want to keep everything else constant, because otherwise, if you have the third thing, you're not going to know which one's actually causing the result. So you only want to have two things that you actually vary. So Gay-Lussac's law says this: at constant volume, okay, Gay-Lussac's law says that at constant volume, the pressure of a gas, okay, the pressure of a gas varies directly with its absolute temperature. Okay, so in one simple sentence, Gay-Lussac's law states that at constant volume, the pressure of a gas varies directly with its absolute temperature. Now let's break down this definition. Okay, first of all, absolute temperature is temperature that's expressed in the unit kelvins. Okay, so temperature can be expressed in Celsius, which is what we use. If you're American, you express it in Fahrenheit, but in scientific terms, we express it in Kelvin. So kelvins is not something you use in different countries. It's a scientific scale that you use when you're talking about scientific theory and things like that. Celsius and Fahrenheit, Australian and American and things like that. Okay, so for you to convert from Celsius to Kelvin, okay, Kelvin is equal to your degree in Celsius plus 273.15. Okay, so if you have 25 degrees Celsius, then you're going to have about 300 degrees in Kelvin, things like that. Okay, so when we talk about gas properties, when we talk about temperature in science, we no longer refer to it as in Celsius. We normally talk about it in kelvins. You're going to get questions that still give it to you in Celsius, because when we're talking about science in everyday life, Celsius is easier to think about. But when you're doing calculations with these laws, you need to be converting Celsius to kelvins by adding 273.15. And then if you want to convert from Celsius back to Kelvin, it's just going to be Kelvin minus 273.15. Okay, now, so that's the first thing. What does it mean for something to vary directly? So pressure varies directly with absolute temperature. What does that mean?
Like, it's not always the same. It's just going to depend on all the other reactions to it.
Yeah, so if pressure is going up, varying directly, what does that mean? What's going to happen to temperature? If pressure goes up, temperature does it go up with it or does it go down?
It goes up with it.
Yeah, good. Okay, so that's what we mean by varying directly versus varying inversely. Okay, so when something varies directly, that means that if one thing goes up, then the other thing is also going to go up with it. And then if temperature goes up, then pressure will also go up. So that's what it means for something to have a direct relationship versus an inversely proportional relationship that we'll see later on. Okay, so Gay-Lussac's law says when you keep volume constant, the pressure of a gas is going to vary directly with its absolute temperature. So pressure goes up, temperature goes up, temperature goes up, pressure will also go up. So if you were to represent this as a graph, if you wanted to represent Gay-Lussac's law as a graph, this is what it would look like. So temperature on your x-axis, pressure on your y-axis, or the other way, doesn't really matter. And in terms of labeling your graphs correctly, okay, in university and the upper levels of science, when you're expressing constants, it's actually expressed after a slash. So normally when you're doing it in high school, you tend to put your constants in brackets, but in higher levels of education like science and university and PhDs and things like that moving forward, they actually do a slash with your units afterwards. So that's why it says slash K for kelvins and then slash PA. PA is measuring pressure in pascals. And another thing is when you're labeling your graphs, you normally do your y-axis versus your x-axis. So in this case, Pressure is on your y-axis, so you do pressure versus temperature. If it was temperature on your y-axis and pressure on your x-axis, then it would actually be temperature versus pressure. That's just a few things to keep in mind. And this graph is showing you this law because as temperature is going up, then your pressure is also going up. So that's showing the directly proportional relationship. Now, if pressure varies directly with temperature, the way you would represent this as an equation would be something like this. P is equal to KT. Okay, so K is just your constant. And in this, relative to this graph, K is sort of like your gradient. Okay, so just like how in maths, Y is equal to mx plus b, in this case, the intercept is at 0, so there is no b. And then x, in this case, is temperature. And then m is just your gradient, which we just don't use the letter m, we just use the letter k. And then you have p over here. Can you give me a thumbs up if that makes sense? If you were to represent this law as an equation, it would be p is equal to kt. Beautiful. Now, if you look at this graph, regardless of where you take the point, would you agree with me that the gradient stays the same? That k value stays the same. So regardless of whether I take the point here, I take the point here, it's a straight line, so the gradient's always the same. Would you agree with that?
Yes.
Okay, good. So regardless of where I take these points, P is equal to KT. So K is going to be P on T, just because I'm moving my equation around. Okay, so let's say, for example, I take a point 1 and then I take another point 2. You told me that because it's a straight line, regardless of where I take the point, it's going to be the same gradient, which means at point 1, P1 on T1, the gradient has to be the same as at point 2, which is P2 on T2. Oh, sorry, P2 on T2. Okay, so this equation right here, the fact that we've been able to relate pressure and temperature at one point with pressure and temperature at another point allows us to calculate our temperature and our pressure if we've done a certain change. So let's say, for example, you know the temperature and pressure of the gas at one point, and then you know that someone changed the temperature to a different temperature. You can use this equation to figure out the new pressure of the gas, because if you know at least 3 variables, you can figure out the 4th, okay? So in terms of which equation is more useful, these equations right here, where you relate one point to the next point, is actually a lot more useful than this equation right here. And a lot of the questions that you're going to get are going to be based on this equation instead, okay? So the P1 on T1 is equal to P2 on T2. And that's the equation that we're going to use to do our practice questions and to prepare for your exams moving forward.